Hi everyone, can't be there with you today. Long story short, my kid got sick over the weekend, and so I am uploading an emergency lesson video for you. As a reminder, yes, the in-class assignment on 3.3 to 3.6 is still going to be tomorrow. That's Wednesday. It's going to be in class. If there are any questions or problems you ran into over the weekend, I didn't receive any email saying, can you help me with this? Can you help me with that? So I'm going to assume that it's okay. But if there was a question you meant to ask me today, but you couldn't find me because I'm not there, email me. Absolutely email me. Okay, don't hesitate. I'm going to get started on the second half of 3.4, and that is inequalities as opposed to equations. I am going to start by talking about when is a function greater than 0, blah, blah, blah. Okay, and then when you have rationals, so fraction functions within that inequality, how do you go about it? And the answer is essentially do the same thing as before. What is the same thing that we did on Friday? It's a word to remind. Do not multiply or divide the denominator. Okay, so a word, how about this? A word about multiplying the denominator to simplify an equation or inequality. You should know by now, don't do it. Okay? And I could give you an example once again, especially if you were not here the other day. Like, consider this. Consider negative 2x plus 4 is greater than a 0. That's just a linear. It's just a linear function. Okay, so if I had to graph it out, it would look something like that. Right? Let's see what the x is supposed to be. If I have 2x plus 4, I'm going to subtract both sides by 4. And then I'm going to divide both sides by negative 2. So that becomes 2. When x is greater than 2, this line is greater than 0. Wait, what? When x is greater than 2, the y value is less than 0, right? It's not greater than 0. What happened? And as you remember, because I divided both sides by negative 2, it's sort of like a reflection has occurred. When this is done, the inequality has to flip. So when x is smaller than negative 2, this statement is true right here. So it gets really, really confusing. So do not multiply or divide the denominator because you may be creating something that you don't want to consider, you don't want to deal with. Okay? It's just unnecessary. So let's talk. Solving for f being greater than or equal to 0. So the answer, if I give you a graph, is very simple. If it's greater than or equal to 0, I'm talking about all of this part from x equals negative 4. I'm talking about all of this part from x equals 2 up to x equals 5, but not touching, of course. And then from 6 all the way to infinity. So if I were to write this out, f of x is going to be greater than or equal to 0 when x belongs to the intervals, let's do it, negative infinity all the way to negative 4, touching, union. Then 2 to 5. 2 I touch because it's an x-intercept. 5 I do not touch, it's a vertical asymptote. Union. From 6 I touch, it's an x-intercept, all the way to positive infinity, which I'll never reach. Okay? So that would be the answer if I gave you a graph. Great. But as you obviously know, drawing a graph is a luxury of time that you may not be able to afford on a quiz or a test. So instead, we solve it algebraically. So to solve an inequality, so for example, if one function is less than another function, you could sketch both functions separately and observe the intersection points. You are encouraged, highly encouraged, however, to rearrange and set one side of the inequality to 0, then solve. So let's do an example. Yeah? Here, instead of multiplying or dividing by x minus 3, you know this, I am going to subtract both sides by 2. So I have this, and I don't have to worry about the inequality. Now let's make the denominators the same. X minus 3 minus 2 x minus 3 over x minus 3. And I'm a big fan of really identifying exactly what I'm doing. I am multiplying by a 1, so that's mathematically legal. And the rest is history. I am going to simplify. I don't want that to be red necessarily. It's not a thing. So the denominator is going to be x minus 3. This is 4 minus 2x and plus 6. And then simplified, negative 2x plus a 10 is over x minus 3. And that has to be greater than 0. Okay, we're basically done. So when have you ever seen, oh, shoot, for the sake of clarity, okay, let's backtrack. When have you ever seen a question like this? You probably haven't. However, you probably have seen a question like that. So what did you do? Right? Well, hopefully with your practice, you remember what you're supposed to do. If I gave you some kind of polynomial and I made that greater than or equal to a 0, do you remember what you did in chapter 2? I hope so. Long story short, you figured out what makes this function in factored form equal to a 0. You figured out where the x-intercept was, and then you figured out when in this function is it going to be under 0. That's what we did. We're going to do the exact same thing. We're going to take this function and figure out when is that equal to a 0. And once you figured out where the x-intercepts are, we can roughly graph. Or maybe not. I don't even want to graph this because even this graphing is so hard. Is there another alternative? If you've done the full practice and you did every single method possible to solve for x-intercepts and to solve for the inequalities, you might have an idea of what might be easier and what might be harder in this case. If not, I'll show you. So here we go. In a situation like this, I am going to check when is it going to be equal to 0, when is it going to be above a 0, when is it going to be below 0. What I'm going to do is pretend this is a question where I must sketch. Okay, I'm basically going to do bits and pieces of dysamic. I factored a negative 2 out so that the numerator and the denominator are both in factored form. I know that the vertical asymptote is x equals 3. And I also know that an x-intercept will exist when x equals a 5. How do I know that? Let me remind you, vertical asymptote comes from, vertical asymptote comes from looking at the denominator. A x-intercept comes from looking at the numerator. So that's why I got the vertical asymptote here, and I got the x-intercept there. Why do I need that? Check it out. Using the vertical asymptote and the x-intercept, I can create my interval chart. So my x is 3, my x is 5. I have a negative 2 as a potential factor. X minus 5, x minus 3, they all change the sign of my function. My 3 is a vertical asymptote. My 5 is a x-intercept. Okay. At this point, if I could ask the substitute to quickly pause the video, have people catch up in following the graph or the chart. Assuming everyone has a chart in front of them now, I am going to simply fill in the numbers. -2, -2, -2, no matter what the x is. If the x is a big negative number, that's a negative, and that's a positive. Negative, positive, positive. Function will be negative. Function, oh gosh, that's my baby. And sorry about that. And that's going to be a negative. So, what does that mean? At this point, if you don't know what we just did, you'll be waiting for, okay, what's next steps? If you know what this does, you will realize you already solved the question. Do you get it? The function, the entire function that we're dealing with, is going to be under a 0 here, and it will be under a 0 here. Does that make sense? The y value is a negative. I am looking for when this y value is under 0. I'm looking for when it's negative. So my answer is here and here. We finished it. So you say, therefore, 4 over x minus 3 will be less than 2. That's the original question. When x belongs to negative infinity all the way to 3, but not touching, union 5, but not touching, all the way to positive infinity. Done. I don't know if that's wild to you, but that's such a simple solution. You think that might be really hard. Like, how do I make this fraction going to be less than 0? All I'm doing is checking, when is this function a negative? That's all we're doing. So use the different tools that you have to communicate. We're just speaking a language here. Let's try this one more time. Okay? Again, if you haven't copied this or you're still lagging behind, you're not sure what's going on, go back and visit the video again on your own time. I'm going to move on to example 3. So same thing. Do not multiply the denominator. Instead, I need you to make one side equal to a 0 and solve. Okay, when you do so, you'll realize, oh, I have a rational expression that's going to be greater than or equal to a 0. And all you need is the interval part of the samic. X plus 6 over x plus 2 minus an x is greater than or equal to 0. I'm going to do this a little fast. Okay, x plus 6 over x plus 2 minus x, oh my gosh, go away, x plus 2 over x plus 2, okay, and then greater than or equal to a 0, and here we go. That's going to turn into x plus 2. And let me see if I could actually close this so that we don't get disturbed. Got it. And then we have x plus 6 minus 6x squared minus 2x is greater than or equal to 0, which means negative x squared minus x plus 6 over x plus 2 greater than or equal to a 0. There's some factoring. So this is what we have. When is this going to be positive? If you want to do that, you're probably going to have to do the parts of the samic, calling for a factoring. This is x squared plus x minus 6. I'm actually going to factor that quickly. X plus 2. Let's see what I can do. Negative x positive 3, x minus 2 over x plus 2. And yes, in case you were hoping for something to happen, it is possible for a whole to occur. In doing so, don't think that's impossible. Okay, and also I probably should have talked about restrictions as well. Let's do the restrictions for this one. Okay, so we've got, oh, well, vertical asymptote. It already sort of pops up. Never mind. Here we go. From here, when is this function going to be positive? Well, I'm going to look at the numerator for x-intercepts. I'm going to look at the denominator for vertical asymptotes. The x-intercepts, I have to check -3 and 2. The vertical asymptote, I have to check for -2. Let's do it. Do-do-do, do-do-do, -3, then -2, then a 2. I have a -1 as my numerator, followed by an x plus 3 and an x minus 2. My denominator has x plus 2, and my overall function, just for ease of viewing. My -3 appears as an x-intercept, so my y value is a 0. My -2 appears as a vertical asymptote, so it's never touching. And my +2 appears as an x-intercept. Minus, 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 minus. Minus, plus, plus, plus. Minus, minus. Plus, nope. Minus, plus. And then minus, minus, plus, plus. We got positive, negative, positive, negative. So assuming my calculations are correct, and you know that they not often are, here's a positive, and here's a positive. These intervals are when this green function is greater than 0 or equal to 0, which means those x-intercepts or those x values are also when this function is greater than that function. Would you rather draw out this function with its x-intercepts and something like this, and then my y equals x, and draw that and look at where the intersections are? Or would you rather just solve by algebra? I prefer solving by algebra because it removes all human error with sketching. Now let's do it. This function, x plus 6, what? Sorry, yeah. Over x plus 2 is going to be greater than or equal to x when x belongs to -infinity all the way to -3, but including union, not including the vertical asymptote, all the way to 2, including. End of question. That's the essence of today's lesson. So using what you've learned and how you've dealt with equations yesterday, you may find that this is actually the same. Just we go off on a different approach once we get to the simplified function, right? Yes, there might be like one extra step, but it should look familiar to you with all the dysamic practice you've done. Okay, so how about this? If the substitute could pause this video and everyone get a chance to try this on your own. We'll do this in, I'm going to say easily 5 minutes, but let's try 10 minutes, and then the substitute can play the video. Okay? Have you tried it? I'm going to assume you did, and I'm going to go about this silently. X plus 1, x minus 4, minus x minus 3, x plus 5, less than or equal to a 0. So this has to be negative. Okay. I'm going to skip some steps. The denominator has to be x minus 4 times x plus 5. This numerator was multiplied by the x plus 5. And the right numerator, x minus 3, was multiplied with x minus 4. And that is all less than or equal to 0. From there, I shall simplify. I'm leaving the denominator as is. I doubt that there's any need to multiply this out. The numerator, however, you should. Minus x squared, let's see, minus 7 plus 7x. So positive 12 minus 12 equals 0. Simplified. Zero. 13x minus 7. X minus 4, x plus 5. Okay, that makes things a little easier because This is a very simple x-intercept to identify, very simple vertical asymptotes to identify. So very roughly, let's do this. My x-intercept, so my vertical asymptote is a -5 as well as a 4. And in between, I have a x-intercept of 7/13, which is not even a 1. I have 13x minus 7. Oh my goodness. Did I not quit this already? Give me a second. I don't know why I'm getting these notifications, even though it's not open on my tray. Anyways, let's keep going. X minus 4, x plus 5, and then here is function. We've got big minus. Minus. I'm going to plug in a 0. That's a minus. Anything above that should be a plus and a plus. VA. VA. 0. Negative, 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 plus, negative, plus, 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 minus, plus, minus, plus. And so we've got this part being less than or equal to a 0, and this part being less than or equal to a 0. Being mindful of vertical asymptotes, I know that x plus 1 over x minus 4 is less than or equal to x minus 3 over x plus 5 when x belongs to negative infinity to negative 5, not touching, union 7/15, comma 4, not touching. There it is. Okay? So again, in short, you're doing the exact same kind of algebra as Friday, except when you get to a simplified function, you're not looking for when it equals a 0. You're looking when this thing is a positive or negative, which means you have to do an interval chart, a number line, or sketch this. But do you really want to sketch this? Probably not. Okay, please practice this. Textbook works very well. Please note, in the textbook, 5A has a typo. I believe this is what the intention was. Whatever they wrote there is incorrect. Number 2, there is also a handout you can work on. And number 3, you can keep on working on dysamic with oblique asymptotes so that you are well prepared for the assignment in class. Okay, hope that was helpful and hope that wasn't too confusing. I hope the volume is okay. I did my best to literally eat the mic so that you can hear me. I'm also going to see if I can provide you a better speaker. Anyway, suffer well, and I'll see you tomorrow.